So in this video, we're going to be discussing how do I determine if a relation is a function. So before we start with talking about a function, let's talk about what is a relation. So we've been seeing a lot of relations in math, and it's just basically a set of ordered pairs. It's something that's relating an x to a y. Showing a relationship there. So one way, obviously, you can represent a relation is by giving a set of ordered pairs. Another way, you can take those ordered pairs and make a table. Another thing you can do is you can take that table and graph it. And then lastly, obviously, you can make a map, and we're going to talk about what a map looks like. Okay, so basically this is a relation right here because I have a couple of ordered pairs here. So it's a relation in terms of a graph. I can show you the same relation just by listing out the ordered pairs. So let's list out the first ordered pair that I have right here. So this ordered pair, my x is 1, 2, 3, 4 is -4. And my y is 1, 2, 3, -3. So that's one of the ordered pairs in the set. The next ordered pair I have is up here. And so the x is 1, 2, 3, so -3. And the y is 1, 2, 3, 4, 5, 6, 7, 8. Then we have this point right here on the origin, so that's just 0, 0. Then we have another point up here, and the x value here is 0, but the y value is +3. This point right here, the x value is 1, and the y value is -2. And the last point that I have here is 3, 3. So 3, 3. The x is 3, and so is the y. Okay, we can show this same relationship as a table. So the way we do a table is we put our x's come first, and our y comes second. So x is always like the input variable. We always think of it as the input variable, so it comes first, and then the y comes second. So the first point I have here is -4 for my x, -3 for my y. Then I have -3, 8. Then I have 0, 0, 0, 3, 1, -2, and 3, 3. And then the way that we would do a map basically connects x values to y values, and it lists out, make that oval just a little bit better. It lists out the y's that you have and the x's that you have. And if you have any x's that happen twice, you don't write them twice. So for example, here an x that happens twice is 0. Here, if a y that happens twice is 3, you're not going to write it twice. You're just going to write it here in order. So my x's are already pretty much in order. So first I'm going to write -4, then I write -3, then 0, then 1, then 3. Now my y's, the smallest y that I have here is -3. Then the next y that I have that's smallest is -2. Then I have 0. Then the next number that I would have is +3, and then 8. Okay, so what a map does is that it takes the x value, and it basically what it does is it maps it to the y by an arrow, by showing an arrow. So I'm going to have a -4 is mapped to -3, according to this first point that I have here. Now -3 is mapped to 8. 0 is mapped to 0, but 0 is also mapped to 3. 1 is mapped to -2, and 3 is mapped to 3. So if you notice, there was 0 that was mapped to 2 people here, and we just had 2 arrows that came out of it. So important parts of a relation, whenever I'm talking about a relation has a domain, which is the set of x values, and a range, which is the set of y values. So we're going to go ahead and write that in there for that definition. So set of x values, and your y's are set of y values. So in this case, it's easiest to see the domain in the last thing that we did. We have our list of numbers. So again, when I'm saying a list of numbers, we want to make sure we're using proper notation. So we're listing out the numbers. If they repeat, we're not saying it twice. So I know that the 0 repeated here for the x, but I'm not going to write it twice. And whenever we're talking about a set, we use these fancy curly brackets to kind of put in our set. So we have -4 in our x's, then we have -3, we have 0, 1, and 3, and then we're going to close that set using those curly brackets. Okay, and then now we're going to go ahead and do our y's. Again, we're using those curly brackets, and then we have -3, -2, 0, 3, and 8. Okay, now a very special type of relation is called a function, and basically what a function is a relation, so a set of ordered pairs where no two ordered pairs have the same x value. So let's come up to the relation we did above. This one would not be a function because this little awkward thing happened here where the 0 was mapped to 0 and it was mapped to 3. So that means I kind of like to think about it like a vending machine. If you pick the number 1, you know what you're going to get out. You're going to get out, let's say, chips. So whatever you plug in, you know what you're going to get out. If you get out something else, if you can get out 2 different things, then the vending machine is broken. Now, you can have something where your output is always the same. That's okay. That's kind of like a vending machine where everything is water. But just think about it. It's the input that can't repeat. Whenever I see an x that happens twice, I know for sure that is not a function. So let's go ahead and determine if this is a function or not. So this first example here, I have 2, 4. 3, 5, 6, 5, and -1, 3. It's a relation where I'm given a set of points. I'm looking at my x's. I have 3, 2, 3, 6, and -1. None of my x's repeat here, so this is a function. Yes, great. It is nice and reliable. I know that if I plug in a 2, I can only get out of 4. If I plug in a 3, I can only get out of 5. If I plug in a 6, I get only out of 5, and if I plug in a -1, I get out of 3. So this is great. Now let's go ahead and list the domain and range for this. So domain is my x's. So we're going to list those in orders. First, I'm going to put in -1, then 2, then 3, and then 6. And then my range is my y's. Again, we're going to put that in order. So the smallest number I have here is 3, and then 4, and then 5. And yes, your range does repeat, but that's okay. That just means if you plug in 3, you can get 5, and if you plug in 6, you can get 5. That's okay. In this case, -4 goes to -3, -2 goes to 5, but 1 goes to 6 and 9. This is not a function. Your 1 repeats here in the x, so no. And then your domain here is just your set of x's, so any relation has a domain and a range. We're going to put that in order, so -4, 2, and 1. It's already in order. That's what's really nice about a map. Let me redo that because my comma looks like another 1. And then my range here is just my y's. So your outputs, -3, 5, 6, and 9. Okay, now in this example above, I'm looking at my x's. Well, this obviously right here has an input of 0, and this also has an input of 0, and I'm getting 2 different numbers. So this is not a function. Your domain here is 0. Well, actually, we had a smaller number here. So -1, then 0, then 1, then 2. Yes, your zeros repeat, but again, it's a list, so I'm not going to write that twice. And then your range, which is your y's or your outputs, you have -1, 1, 3, 5, and 7. Okay, now let's talk about how to figure that out from a graph. So for a graph, basically, again, you're looking here at your x's. making sure that your x's don't repeat. And so we do something called the vertical line test. It basically like makes your eyes look specifically at the x values and make sure you don't have 2 points for any x. So no, you make a vertical line and no 2 points on a vertical line. That's going to make sure that you don't have 2 points that have the same x value. So let's go and make one. So let's try to use this tool here. Okay, let's go and make this so we can see it. If I were doing this on paper, then obviously I would use probably my pencil or something, and kind of like that's going to allow me to just move it around. So I'm going to check, okay, does this line ever hit twice? No, it doesn't. So this is a function, yes. There are no repeating x's wherever I look. Okay, so I'm going to take my vertical line and we're going to do it on this function. Okay, when I do it on this function, I see multiple times that my x, I have 2 points that do have the same x value right here. So this is not a function, no. Okay, so that is the end of this video, and I hope you found this useful for understanding what is a function and how to tell when a relation is a function.